Okay, hello everybody. I'm just going to make a hopefully not too long video about the mystery tone exercise, which was due on Friday. I downloaded all of your submissions for this yesterday, and Dushan's working on grading them. You should get them back soon, but it was clear when looking at them sort of where most of the confusions lay. It was not clear to me what the problem was, I guess, during the review session itself. So yeah, now that we've communicated a little bit better, I think I can help you out a little bit more with what to do or what you should have done with this exercise. And hopefully it will be applicable for the midterm tomorrow as well. If you're going to watch this, that is, in time. So I'll just kind of walk you through kind of the crux of this exercise, which is determining how many contrastive tones there are in the language. So it's a language that we don't know. You'll find out by the end of this video and when you get the key for this exercise too, what language it actually is. But the goal is to figure out what are the contrastive tones, and there are 20 different sound files you have to work from. So like I'm giving you an example here of Mandarin, which has 4 different distinctive tones. I can tell you, I believe, so Cantonese has 6, maybe 9, depending on how you count. And I believe Thai has 5. Like usually if there's a contour tone language out there, it's going to have somewhere in that neighborhood of tones, sort of usually less than 10. So first of all, there are a number of people who said there were like 14 contrastive tones or 17 or like many different contrastive tones. I think actually somebody had more than 20. So there's no way you could find out if there's more than 20 based on 20 sound files. So just try to, like, if you don't have experience with these languages, then you wouldn't know. But something like 4 or 5 contrastive tones is pretty typical. 20 would be like out of this world. But you know, it's possible, just not super likely. And also because I want you to kind of try to match up tones across words in this like sound file set, it wouldn't really make sense for there to be 20 altogether or more than that. So what I had in mind for you to do is I'll just walk you through kind of the process. Like let's open up this first one, and actually let's listen to it first of all. Maybe we can turn that up a bit. Yeah, so this is a tone language. So the F0 pattern is going to change from one syllable to another, and it has to kind of adhere to a specific kind of contour type. So that first sound file, it's pretty level, right? And it's kind of, I don't know, maybe it sounds middling to you, maybe it doesn't. We can find out better if we listen to other sound files to find out like where her pitch range is, basically. So again, I'll just start off by listening to them without showing you the pitch contour, because it helps to kind of get a sense of what these sound like just impressionistically before you start doing these sort of quantitative analysis. Let's play like the first 5. That sounds like, the second one sounds like it's falling a little bit. The third one kind of sounds like it's higher than the first and maybe staying up high. That's kind of midish. That's higher in pitch. I think you can hear that, but still level. And that one kind of rises a little bit, right? Something like that. And number 5. G. That one kind of falls a little bit. So we've got basically like a level tone, a little bit of a falling tone, a level tone but higher in frequency or pitch, a rising tone, G, and a falling tone, right? And so I'm kind of already going straight to sort of these descriptions of the tones. We don't know how many different contrastive tones there are yet, but you can kind of just by listening to them get a sense of where F0 goes or where it starts off and where it ends. So you can just talk about it in terms of whether it's level, rising, or falling, that sort of thing. And once you hear enough of these, you should be able to get a sense of like where the levels are. So we can also look at the pitch tracker to help us out. If you didn't use this or didn't know how to use this, again, the way you turn it on, I'll turn it off here, is through pitch and then show pitch. And then this blue line appears in your sound file, which shows you what Pratt's best guess is. Pratt's best guess is for the F0 at any one moment in time. This one's kind of a nice little example. It's the very first sound file. And hopefully you can hear there's a nasal M at the beginning. and then a vowel here. Not a vowel that we have in English, but it doesn't really matter. It's just different from this nasal at the start, right? So in the vowel itself, it sounds like that F0 is level pretty consistently. And you can click on this blue line to find out exactly what Prot thinks the F0 is. And it's basically about 230 hertz at any one point in time, maybe a little bit above, maybe a little bit below. So that is how many times per second the vocal folds are opening and closing. 230 hertz, that's about average for an adult female speaker. We talked about this in the lectures, but 220 hertz is on average kind of throughout the world where you'd expect an average adult female speaker's F0 to be. So this is just a little bit above that. So you can kind of use that as a bit of a frame of reference. It's a little bit lower here in the M, but this is kind of typical. So this is maybe around 210 hertz or so. You can read the frequency over on this side, on the right-hand side. But it doesn't sound like it's some dramatic change between the M and the vowel, right? This is what we would call a micro-perturbation effect, where there's just kind of an effect of the consonant, or sort of the consonant to vowel transition has a small effect on the actual specific value of F0 for this speaker, but it's not like a tone shift per se. So, just impressionistically, again, I think of that as basically a level tone somewhere in the middle of the speaker's range. Otherwise, it's not any more exciting than that. And we can kind of put that in the, the bank account of our tone mind and move on to others and see how they compare. Because what we're going to want to find here are other words that kind of match in terms of their F0 contours. So like I said, we listened to this one, and it sounds like it falls a little bit. So you can at least get a bit of an impressionistic view that this one's kind of falling rather than staying in one spot rather than being level. And we can see that in the F0 contour here as well. So this one starts out at about 243 hertz, and then it drops down to a relatively level 201 hertz. So it starts out higher than that first tone does, and then it drops down lower. And it's a kind of a subtle shift, but you can hear it if you're just listening, focusing only on that pitch change. Otherwise, it stays the same. So let's keep going. And hopefully somewhere through here we'll find a match of some sort. This is the one I said it sounds level, but it's higher than that first sound file level. And we can quantify this now with the pitch tracker. So this one's around 270 hertz all the way through. The initial consonant here is an F, or something like it, and that doesn't have any voicing in it, so that's not going to mess around with the F0 at all because there's no F0 in the voiceless fricative. We just have it during the vowel there. And we can compare that to sound file 1A, and just directly see and hear that those are not the same tone levels. Right? That one's higher pitched than this first one we listened to. Yeah, and it's subtle, and unless you're like strictly listening for it, you might not notice it if you're not a speaker of a tone language, but that difference is there. And when you pay attention to it, it becomes fairly obvious, I think. Let's listen to number 4. That's the one that was rising. And it starts out here at 170 hertz or thereabouts. And at the end, it is up at 270 hertz. So that's about a rise of about 100 hertz, which is nice. Nice and clear, at least. It does a little thing like it kind of drops a little bit here at the end. Like I said before, these minor changes in F0, you can't take too seriously, like this little blip or that little blip here at the end. Just listen for the overall pattern. And the overall pattern here is starting relatively low, moving to a relatively high F0. High F0. Number 5. Let's look and listen to that one.
G.
Yeah, so this one is kind of a short falling tone.
G.
It's got this affricate at the beginning, which starts with a voiced stop. So hopefully you can hear that. If you can't hear that, you can just select this part of the sound file and listen for it. That's the voicing while her vocal tract is closed. So that kind of voicing, because the vocal tract isn't open, isn't going to kind of work as smoothly as it does when you have a vowel like that. So Prot's looking for the best estimate for the pitch during this voice stop. It's coming up with something kind of funky here. Basically, don't worry too much about that. What's going on in the consonants. Focus again more on what happens during the vowel. And what happens during the vowel here is that it falls kind of briefly, not too sharply, but noticeably, I guess you could say. So it's going from about 265 hertz at the beginning to 207 hertz. And you could say here, well, at the beginning, it's a little bit lower. And maybe that means something. Maybe that's typical for this pattern as well. It might, though, also just be an effect of this fricative right before it. Like I said, consonants and vowels kind of affect each other in terms of F0. So me just listening to this, I don't really hear that. Again, I'm not a speaker of a tone language either. I'm not a speaker of this tone language in particular, so I wouldn't really necessarily notice it. But you can maybe make a note that it starts out a little bit lower, but what you hear, I think, is mostly that short fall. So that's kind of what I would keep track of for this one, about 270 to 210. Either way, we still haven't found matches here for any of these. We can listen and look at number 6.
Dang. Dang.
And all of a sudden, if we go back through our list, maybe we found something that matches.
Mo.
So listen to number 1,
Mo.
compare it to number 6.
Dang.
Those are pretty close.
Mo. Dang.
Yeah, we can compare them to the other 5, right? So
Mo.
number 2,
Bei.
falling,
Feng.
high level,
Ao.
rising,
Ji.
short falling, and then this one
Dang.
is about at that level. And if we measure it, that helps us kind of confirm even more that they're almost exactly at the same F0. So this is right about 230. It's like about 229 hertz here, maybe a little bit above, maybe a little bit below that. But it's basically almost exactly the same as what we had for sound file number 1 for this vowel part of it.
Bo.
Starting from here.
Bo.
Versus...
Dang.
Yeah, that F0 is the same, and that's good enough evidence for you to say these are the same tone across these 2 different sound files. So that's one contrastive tone. It's not really a minimal pair in the usual sense because the segments differ between these 2 productions, these 2 words.
Mo. Dang.
In terms of both their consonant and vowel, but you can hear that the tone is the same. So the tone is staying the same and the segments are switching. So it's a minimal pair, I guess, in that sense. It's a segmental minimal pair, sort of, or a syllabic minimal pair, if you will. I'm going to stop walking through these in this fashion because after we get past 6, there's a lot to remember, and you kind of have to start keeping score when you get past 7 because you can't really keep it all in memory, I don't think. But that's the idea, is to look for matches like these 2.
Mo. Dang.
And yeah, so I'm going to show you how a couple of different students did this because, like I said, I looked through your homeworks briefly, and I noticed a couple of different approaches which looked like they worked well. So this is the key. I'll skip that for a second. I'm going to go to Maya's homework because she specifically said that, or she specifically asked me if she could put like her process in there, which is great because this is kind of a homework that's about process more than anything else. So I'll skip this part at the top and just show you kind of what she did at the bottom, which is great, which is she just plots out the different frequency contours for all the different tones. And we've looked at the first 6 here. And like mid-level, kind of mid-falling is what she calls number 2. High level for number 3. Mid-rising for number 4. Another kind of mid-rising, but she kind of got that kind of up-down pattern for number 5 that we talked about briefly. And then gets to number 6 here and says it's mid-level. And I don't know exactly what she did here, but it kind of looks like she's matching things up because she's got a filled-in circle here for number 1 and number 6 to indicate that they're basically the same, which is cool. But like I said, because there's 20 of these, there's a lot to keep in mind. So you have to write them all down or keep score, like I said, and then try to find matches between various sound files across the whole collection. And also, another thing she did here, which is great, is that she came up with kind of approximate frequencies for the different tone levels and sort of the level description that we use for tone transcription. So like I said, you kind of want to come up with a range from like 1 through 5 for the tone contours when you transcribe them, with 5 being the highest frequency and 1 being the lowest. So she's got kind of a key here of like 130 to 170 being 1, 180 to I guess 220 being 2, 230 to looks like 250 for 3, so on and so forth, all the way up to 325. So that ties into another like task I wanted you all to do, which is to find the pitch range that the speaker uses. And then list the low end and the high end, and then it's even more informative if you kind of match that up to different levels, 1, 2, 3, 4, 5 throughout. So now that she's got that, we can look at like this mid-level tone and say, well, that's just like a 3-3 tone, right? It's right in this 3 range throughout, and we can transcribe both 1 and 6 with that 3-3 tone for both syllables. Going to say number 4, it starts off low, and for her range, it would be like a 1 at the start, and 270 leads up to like a 4. I don't know if that's exactly how she transcribed it. Maybe not. But at least she's got that in there. Like she calls it a low rising tone. Was that number 4? Number 4, yeah. So this one, yeah, 1, 4. And she's got it listed here in her table of contrastive tones as well. Another thing which Maya did, which is good, is she matched up the number of contrastive tones for this task number 2 question with the number of tones in her table. I guess it's kind of overkill for me to give you this task 2 and say determine how many contrastive tones there are in the language. And then I'll also ask you to list a table of all the distinctive tones, excuse me. But I'm kind of glad I did that because some people seem to not realize that there was a connection between those two. So, so a number of people were listing like saying there are 4 contrastive tones for this second task and then listing like 8 different tone contours. But like if you have a tone listed in this table, it's got to be contrastive basically. So those 2 numbers have to match up. Yeah, and it's good that hers do. So that's excellent work all around. And like I said, I'm going to show you the key to this exercise, which I got from the original speaker of the samples, who was a former student in this class. But I don't really care that much if you get it exactly right. I care if you actually do all the steps that I wanted you to do to try to figure out what's going on in this language. This is hard, especially if you haven't listened to it before. So I just kind of want you to go through the difficulty of the process of not knowing and getting some information out of something you don't know anything about ahead of time. So Maya did this all the way. I wanted her to do it. I wanted you all to do it. With listing the number of tones, listing the pitch range, listing the specific tone contours she gets for each tone category, and then transcribing it. And this is not all going to match up what the key is supposed to be, but it doesn't matter because every single element is in place there. And it's also really nice that she laid out her process. So that's, one way we can figure out how she did this, which I think is pretty accessible to anybody who does this. I'm also going to list out the very first homework I saw, which was from Lauren. I apologize, Lauren, for highlighting you like this, but you're first in the alphabet, so you're the first one I noticed. But she did something similar, listing out sort of the specific ranges of frequencies from 1 to 5, and then using that to sort of guide her descriptions of the tones in terms of like the frequency contour for each tone label or category. Yeah, and then she has different kind of labels here, which are some are interesting. So full falling, I kind of like that, full rising, peak dip, so on and so forth. Yeah, this is all works out. This is kind of what we wanted you to do. And then she comes up with her transcriptions here at the bottom. Also, a few notes about why she made the decisions she made. That's great as well. Again, when you're doing science, you want to be able to communicate what you're doing to other people so they can understand it, and if necessary, do it themselves. And this is a great way to do that all throughout. We can kind of compare this to the key I got from the original speaker of these sound files. Her name was Michelle Liu. She was a former student in our undergraduate program and also a former MA student in our program as well, sort of about 5-6 years ago. Excuse me. and she's a native speaker of a language called Yueqing, which is the language in this exercise. So she came up with this exercise because part of why she was into linguistics was because her language, which is a Chinese language, is threatened. I guess it's endangered in terms of how many people are speaking it, because young people are not picking it up so much anymore. They prefer to learn how to speak a language like Mandarin instead, because that opens up more doors for them around the world. So she wanted people to be able to hear this language before it goes away completely, and here we are. And this is the sort of guide she came up with for it. And I've added a few things to it, so we can kind of look at it in comparison to Lauren's, and you'll see it matches up pretty closely. Again, it doesn't have to be exact, but if it's if all the elements are in place, we'll give you full credit for the exercise, and then we could squabble about the details later on. But like this first one is labeled as a 3/3 tone. Same thing for number 6, and Lauren got the transcriptions right there as well, which is great. And then there's minor differences here too. So Michelle had this number 2 labeled as 3/2. You might remember that's the one that's falling just a little bit for number 2. Like that. So that's like a 3/2 tone. This number 3 is labeled as 5/5. In Lauren's assignment, I think Michelle had it labeled as 4/4, so on and so forth. It's maybe not at the top of her range, but either way, it's the right idea. And then you can kind of just walk through the rest of these, but I'll play you some of the ones that match up, I guess, so you can hear where the categories lie. So number 8 and number 11 are supposed to be the same category.
记上
And hopefully you can hear that. Number 5, we heard that one before, is kind of the low falling.
记
It's supposed to match up with these two.
让不
Yeah, some of those are kind of easier to interpret than others. 7, 15, and 18.
和十角
In each of these categories, you should hear that tone contour sounding the same, as if you're sort of superimposing different segments on top of the same sort of F0 pattern. Number 4 and 12.
熬角
Is that rising one? That one's a little tricky. It's easier to hear the rising in number 4
熬
than when you have the fricative at the beginning.
角
But it's there. Number 3,
风
17,
汤
and 19.
戳
Those all sound pretty similar F0 wise. I'm not going to do category number 6 because we've heard it enough at this point. Category 7 is 2 and 14.
背棍
That's kind of the little bit of a falling,
背
which Michelle labeled as high dipping.
棍
And then the low dipping is 10, 13, and 20.
咋背虐
Yeah, so I mean, there's room for discussion in there. Again, I was taking the key from Michelle's analysis of her own language, but you might hear fewer, less, or more categories in there. And again, as far as I'm concerned for your homeworks, as long as you know how to justify the decisions you made, that's fine. And again, trying to get all the pieces in place in terms of the analysis. And the specifics we can squabble about later and maybe come to a consensus about as a group. Unfortunately, we can't do that right now. I just wanted to get this out and done for you all before the midterm in case this is useful for you. I'm going to show you one other stupid little trick before I say goodbye. You can change a sound file into just sort of the F0 contour, i.e. get rid of the segments in prot, by changing it to a pitch object like that. So you highlight the sound file and say analyze periodicity to pitch, and just leave this as it is and hit OK. Now you have this thing called a pitch object. You can view and edit that, and it shows you basically its own rationale behind guessing what the F0 values are at any point in time. But if you play this thing, it's just the utterance produced as if it was a schwa all the way through, like that. We can try the same thing with number 2. Change it to a pitch object, view and edit. Yeah, it's obviously not the same tone contour as that. And this kind of gets the segments out of the way so that you can maybe hear that a little bit better. Sound 6, we can do the same thing because that does match up. Let's just give that a listen briefly and compare it to both of the others. And this is where we get into a little bit of trouble with that weird voicing in the D of the affricate. So I'll just kind of cut that out and just play that part, compare it to this. Or maybe just the vowel part again. That's basically the same thing, right? And it's also clearly different from number 2, which falls, right? Okay, that's just kind of for fun. If you want, you can record yourself saying something in prot and do the same trick, change everything you said into a schwa, and you can laugh at it yourself at home without having to embarrass yourself in front of everybody else. But it's just for fun, and also, I think, a little bit of better understanding about what's going on here with the tone contours. Okay, that's all I'm going to say about that for now. I've got a number of other videos I have to make before tomorrow, so I'm going to work on those. But yeah, hopefully this is helpful, and I'll see you again soon.